Welcome back one and all. Today we're talking about the subject physics. So today we're going to talk about electrical conductivity and its derivation, uh, which is this sigma, which is the representation of electrical conductivity, is equal to Ne square T by N. A is the relaxation time. We can also refer it as tau, but in this derivation, in the whole derivation, we refer relaxation time as T. So let's start with the derivation expression for electrical conductivity of matter. So first of all, what is electrical conductivity? Uh, to define electrical conductivity, let's go through the formula once and then define it. So formula is sigma equal to, where sigma is the electrical conductivity, Q by T A E, where T is the relaxation time, A is the area of cross section, and E is the applied electric field. So to define electrical conductivity is the amount of charge per unit area, uh, per unit cross section uh, on the applied electric field per unit time. So that's what we define in the definition too. That is the quantity of electrical charge, which is the amount of electrical charge I said, flown through the metal per unit time across unit area of cross section per unit applied electric field. And its unit is ohm inverse meter inverse, or 1 by ohm meter. So to start the derivation, we need to take a scenario, or we need to imagine a few things. So let's say we have a metal bar where you apply an electric field to the metal bar. So the metal bar has n number of electrons, 3 electrons. So these electrons experience drift velocity and move and have a drift motion, or they undergo a drift motion. So when these electrons move in the opposite direction of the electric field. So when this happens, as you see, the force of the applied by the electrons is given as F equal to minus E into E. So where F is the force applied by the free electrons because of the electric field, minus E is the charge of the electron, and E is the applied force, applied electrical field on the free electrons in the metal piece. And relaxation time is the time taken by the electrons or the free electrons in the metal to move around. So another equation for force is m into a, where m is the mass of the electron and a is the acceleration. So this is given by us from Newton's second law of motion. So taking the first equation and second equation, we get minus E into electric field E is equal to mass into acceleration. So we got this from the equation 1 and equation 2. So from this we get acceleration as minus E, as you see here. It's minus E into E by M. Now let's take this as equation 3 and keep it aside. So acceleration A is equal to drift velocity Vt by relaxation time. So substituting this equation 4 and equation 3, you can see below that we get the equation Vd by T is equal to minus E into electric field E by M, where Vd is the drift velocity and T is the relaxation time. Now again, equating this equation, we get Vd, drift velocity, is equal to minus E into E T by M. So we still haven't derived the expression for electrical conductivity. So from this equation, we need to derive. So charge density of a metal, it has way many formulas. We're going to use two formulas of charge density right now. So the first formula we're going to take is J is equal to, where J is the current density, J is equal to n into minus E into Vt, where n is the number of electrons and E is minus E, the charge of the electron, and Vt is the jet velocity. So equating this equation 6, we get Vd is equal to J, current density, divided by n into V, or minus n into V. So substituting this equation in equation 5, we get J is equal to n into minus E into E into T by, where J is equal to n E square into Et by n. So this is the equation work. We still haven't got the equation for the electric conductivity. As we said, we're going to use two formulas for two formulas of charge density. The other formula is J is equal to sigma tau, sigma E, sorry, my bad. J is equal to sigma E. That's J is the current density, sigma is the uh, electrical conductivity, and E is the applied electricity. So now we have got in this equation we have the electrical conductivity. Now we take the electrical conductivity sigma equal to J by E. So or substituting, since J has we in this previous equations take charge density is equal to me square into Et by m, and in the eighth equation, as you see, the new charge density formula, we get J is equal to sigma E. So equating these two equations or comparing these two equations, we get sigma E is equal to me square Et vector. Now cancelling the electric fields on both the sides, we get sigma is equal to me square T by m. This is the final formula for electrical conductivity. The general formula is me square tau by m, where tau is the relaxation time. In this derivation, we have used t, small t instead of tau. But still, the derivation and the formula is the same except for the representation. So this was the derivation for electrical conductivity, or the derivation of electrical conductivity. That's it for this video. Thank you.